Alright, good day and welcome to this episode of Engineering Mathematics Part 2. And the first topic we are going to be treating is vectors. So we've heard a lot about vectors and we know that it's a physical quantity. So we have scalars, we have vectors. What are scalars? Scalars are quantity that has only magnitude in their operation. We can say Adi walks in a kilometer or 5 kilometer. So, but we don't know where he's going. But when we deal with vector, we say that Adi goes 5 kilometer, maybe due west or due south or due north or anywhere. So that is involving direction. So and that's what vector is all about. It has to do with magnitude and direction. So those keywords, those two keywords, we are going to be taking note of. So when we say vector, let me just define. Vector is a physical quantity that possess magnitude and direction. Now, it possesses magnitude and direction. Now, let's take a line AB as an example. So we say we have a line AB. This line is the magnitude, right? So we have AB. AB. So how do we indicate the direction? We indicate direction by arrowhead. What do I mean by arrowhead? This is an arrowhead. Yes. So this is telling us that this vector here, it is vector AB. Why? Because it's moving from A to B, as you can see the arrow. So if you want to write this vector, I will say this vector is what? Vector AB. Now, this vector, I can turn this arrow back, and if you turn to what? Vector BA. In that case, I will have something like this. And I will say the same AB. But this time around, it is already BA. Why? Because that vector is moving from what? B to A. So you can see the difference. So now, this AB is also the same thing as minus BA. Minus vector BA. Why this BA is also the same thing as minus vector AB. So we have to take note of that. So because when we get into component of vectors, we are going to be, doing some changing. Maybe we want to prove some vectors to be correct or not, so that we will know the usefulness of the direction of the vector. So that's the purpose of this. The arrowhead indicates the direction, the line indicates the magnitude. Also the same thing here, the arrowhead indicates the direction, then the line indicates the magnitude. You can also call magnitude size. It's also called size. So for example, I said the other time, let's assume this place is 5 kilometer, just as an assumption. So maybe Ade moves from A to B, a 5 kilometer journey from A to B. But how do you know the direction of where it's going? It's through this arrowhead, and that is what indicates the vector. So the vector is going to be what? Vector AB is moving this way. So in 5 kilometer, that 5 kilometer is the magnitude, while this direction is the what? Is that arrowhead is showing the direction rather. So without wasting much of our time, we are going to moving from here. Let's look at addition of vectors. So this is a very simple concept. We can take in consideration vector PQ plus vector QR. Let's see, we have vector PQ plus vector QR. What will this give us? Now let's bring it out in the diagram. We have vector PQ and we have vector QR. You say this is P, you say this is Q, and you say this is R. Now, the resultant will be what? From here to here, right? So, and that is what? Vector PR. Now, let's add the direction to it. Now, we say vector PQ because it's moving from here to here. And we say vector QR because it's moving from here to here, right? So, now, the resultant will be what? PR. So, we have this arrowhead here as the resultant. So, our vector PQ plus QR will give us vector PR. So that's for that. And let's take in consideration also some vectors that do accumulate. We have accumulative vectors. For example, let me take vector AB plus BC plus maybe CD and DE. It's accumulative. Now you can see from here we have vector AB, and from here to here we have BC, and from here to here we have CD, and from here to here we have DE. So now we have something like this here, and we can add some line at the middle here. So what is it telling us? Vector AD, this direction. Okay, let me use this direction. Then vector BC, this direction. Vector CD, this direction. And vector DE, this direction. So the sum of all this will accumulate to give us vector AE. Right? If you are solving this also, you will see that AB plus BC, that's AC, then CD plus DE, that's CE. Then you can also add what you got here, which is AC plus CE. It's going to give you what? AE at the end of the day. So explaining with diagram, you can see that the flow of direction is accumulating to this. You can see if you go through a journey of this place, you can choose to pass this short place just to reach it instead of passing through all this. So it's still the same thing. So you have AE as your answer. Yeah, AE. So yes, let's go into examples. Let's deal with this. We have find the sum of vector AB minus vector CB plus vector CD minus vector ED. Now the first thing to do is to bring the minus back to plus. Like you have to flip it, and we did something here the other time when we were explaining the vector representation. I told us that when we have vector AB, it's also the same thing as minus AB. So here now, if you are turning CB backward, if you are writing another form of CB, it's going to be what? Plus BC. So we can say that minus CB equals to BC, right? Also for this is ED, right? We can say minus ED, vector minus ED is equals to DE. Yes. So now we can insert these two, we can insert them here, and we can proceed. So here we'll be having vector AB plus what? BC, vector BC plus vector CD, and ED is now what? Minus ED is now what? Plus DE. So here we can solve for that. When you have vector AB plus vector BC, it will accumulate to what? AC. Just notice that this cancels, and you have AC. It's a long journey, indicating with diagram. We already understand it from all this place. So we have AC here, AC plus, then here you can see CD, vector CD plus vector DE. We have this cancel that, so you have CE there, and our final answer will be what? You also have this cancel that, and you have AE as your final answer. That's what we represented here the other time. So moving to the next example, on the right side we have GH plus HG plus JK plus KL plus FG. Now find this one. It's very simple, still the same process. You can see that from here this can cancel, we have GJ. Also from here K can cancel, we have JL, then we sum up the remaining. We don't have any minus here. So from here we have GH plus HG will give us GJ. We all know that this will cancel this here. So after that, plus this will give us what? JL. These are simple concepts. Then we have this one, last man standing here. So what do? Either bring this together or bring this together. Is there anyone you choose? So let's use this. We have G what? GL plus LG. Now, what does this gives us? You can see that this GL is also minus what? This FG rather is also minus GL. Remember what I did here the other time? AB is also minus DA. So you can say that LG is also what? Minus GL. And when you bring that together, it's going to give us what? 0. That's what we call a closed loop vector. A closed loop vector. So we have GL minus GL, because my plus LG also is written as minus GL, so that will be 0, and we call it closed loop vector. A closed loop vector, because it's as if you are going front and you are coming back again. That's just it. You went to the front by 5 kilometers, you came back again by 5 kilometers. You see, there's nothing, it will lead to 0. So that's what we did here. Now, components of a vector. Component of a vector. This has to do with it's still almost related with the resultant, but in this case you have another part that vectors pass through, because you can see, for example, now let me see AP. You have line AP here, knowing where that this is going this way. You can also have components in a way that can go this way, come here, and still come and end at P. So that is just it. So this is vector AP, or you can say we have maybe BC. So you can say that this is vector AP equals to vector AB plus vector BC and vector CP. Just an example though. Now let's move into the main question here. This is the last question in this episode. Now ABCD is equilateral with GH being the midpoint of DA and BC respectively. Show that AB plus DC is equals to 2GH. Now, firstly, you have to know how to interpret question. They told us that we are considering a quadrilateral. What's a quadrilateral? You draw your quadrilateral. You have this in consideration. These are quadrilateral. Now, quadrilateral is ABCD. ABCD. Let's do that. You have A, B, C, D. Okay. Now, it said with G being the midpoint of this, that means G is the midpoint of DA. That means you have G around here. G. That's the midpoint here. Then H being the midpoint of BC. That means we have H here. Okay. Now, you know that we have a line from here to here. That's the midpoint of both lines. Now, we now say we should show that AB, let's put the direction now. We have AB, this is the direction. Then plus DC, we have DC here. That means we have a direction going this way also. So put the direction equals to 2GH. This is what we have to ask to prove. Prove that this equals this. How? First thing you do is to define what you were given. Define every vector you were given. You were given AB, you were given DC. Let's define those vectors. Now you are going to define AB. It has components. If you are not going to pass, if let me use AD again. If AD is not going to pass through this place, you can pass here, and arrive here at that same destination. So now we are saying it's passing through AG, then GH, then coming back to what? HB. That's going to give us AB back. So we can say AB is what? Vector AG plus vector GH plus vector HB. We grab. Now we've defined the first vector they give us, which is AB. Now the second one, DC, is also coming this way. So you can go through this place, come here and land here. So what are we having? We are having DC equals to vector DG plus GH and HC. Now we've successfully defined both vectors. Now what's the next step? We are taking both related entities together to solve to prove this. Now what are the related stuff here? I already arranged it the way it is related. You can see this is related. Why? Because they are on the same line here. AG, DG. Now let me put this arrow here. They are on the same line, though they are opposing each other, but they are still on the same line. Now, then we have GH also here. These are related for sure. You can see that it's the same thing. So this also is related. We have HB and HC. They are also on the same line. So that's why we are picking them together. So now Picking this and this together, we have let me come here. You see AB plus DC. Now let's put everything together. We have AG plus GH plus HB plus DG plus GH plus HC. Now let's group them. Now. Maybe this one is for this and this one is for this before. So now we can pick this together. We have AG plus DG, then plus HB plus HC, then of course we have 2 GH here. GH plus GH will give us 2 GH. We are getting closer to our result. So we have plus 2 vector GH. Now, as we all know that this DG is opposing AG here. So I want to make this DG, I want to write another form for it, this DG. So what am I going to write? You can see that it's opposing AG, but if I want to make it AG, it's going to be minus AG. Why? Because it is opposing it, and I want to make it look like that AG. So that means I'm changing this direction. I'm changing this direction to this way, down, coming downwards. So that means that DG is also known as what? This DG is also known as what? Minus AG. Because you see, before it was opposing AG. So I turned it to direction of AG, making it minus AG. Can you understand that? So making it minus AG. So secondly, for this also, HC, I can write another form for it. As you can see, they are opposing each other. This one, they are going opposite each other. This one, they are facing each other. This one, they are opposing each other. So now, we are going to write another form for HC. Since it is opposing HB, it's going to be, if you are turning this one now back upwards, going up, it's going to be minus HB. So we have minus HB. So now, let's insert our new quantities into the question. We have AG minus AG plus HB minus HB, then plus 2GH. And we can see that this one will amount to 0, 0, and we have what? Our plus 2GH, which means that AB plus DC is what? 2GH. So this is the end of this video. Do well to like, share, subscribe, and engage in our videos as going to be coming. This is just the first part. We are still going to be doing more of this. Thank you very much. God bless you.